Okay, welcome to video 3, where I have two more examples to show you. Here's an integral of x squared times sine of x to the third dx. This one is obviously super ugly. We're going to clean it up with a u-substitution. Typically, for your u, you'll select what's in parentheses. Another hint or idea is to select a u that has a higher power. So if I did select x to the third, isn't the derivative 3x squared? And so I kind of see that the derivative, part of the derivative is sitting right there. So if I pick the higher power and I compute the derivative, that's 3x squared. I'm going to go ahead and multiply both sides by dx, and I get du equals 3x squared dx. And I see that I have x squared here, and I have the dx here. You don't have to, but you could rewrite this if you wanted, to where you have the x squared dx next to each other. It's not necessary, but sometimes it helps students. And they can see that they have x squared dx, x squared dx. I just don't have that other 3. So that's why we're going to divide by 3, and it's okay to divide by a number. So I'm going to get 1/3 du equals x squared dx. When I rewrite this integral, the x to the third becomes u, because that was what I said at the beginning, and then x squared dx becomes 1/3 du. Just like the previous examples, we can pull this 1/3 straight out to the front. So I have 1/3 times the integral of sine of u du. Remember, the whole purpose of a u substitution is to take a really ugly integral, clean it up into something more manageable, and we definitely did that. We can bring this 1/3 down, and the antiderivative of sine of u is either cosine u or negative cosine u. And so the derivative of anything that starts with a c is a negative. Don't forget your plus c. I'm going to clean this up a couple different ways. I'm definitely going to put my u back in. Multiply this negative times the 1/3 out front. Cosine of x to the third plus c. As I mentioned before, you can always take your answer and you can check it mentally or go to the side and do the derivative of it. If I did the derivative of negative 1/3 cosine x to the third plus c, I know the derivative of c is 0, but if I did this derivative, negative 1/3 times, the derivative of cosine is negative sine x to the third times the derivative of x to the third, and derivative of constant is 0. Looking at cleaning all this up, a negative times a negative is a positive. The 1/3 times the 3 cancel. And so I just have sine of x to the third times x squared, which you'll notice is exactly what I started with at the very beginning, just in a different order. And multiplication is commutative. You can move it around. Now, one last example. This one is very different. It's still got sine and cosine in it, but it's definitely worth mentioning because this is the one where students get confused on what u to select. So that's sine of x to the 4th power times cosine of x. So I'd like you to pause and try to write down a u. Okay, if you've resumed, selecting u is very difficult on this one. You could pick sine of x, you could pick cosine of x, you could pick sine of x to the 4th power. It's, like I said before, typically you want to pick the function that is in the parentheses, and if you were going to put this in your calculator, which we can't because it's not a definite integral, I would have to put parentheses around the sine of x. That's how I'd have to get it in my calculator, and I think your calculator would put parentheses here. But that's the only way to get this in your calculator. So the u is the parentheses, sine of x, not the 4th power. because when I rewrite this integral, I'm going to have u to the 4th power. That's what's going to happen right here. This will become u, and I'll have u to the 4th. The derivative of sine is cosine, and if I solve for du, I'll have cosine x times dx, which is exactly what is happening right here. So this became a very, very much more manageable integral than this one. This was so ugly and messy. Once again, that's the purpose of a u-substitution. So I'm going to add 1 and divide by the new exponent. Don't forget to replace the u with what you started with. You said that was sine, and some students will do this. And that is actually wrong, because that says the x is to the 5th power, and I want the sine to be to the 5th power. So I need to either put parentheses or I need to put the 5 right there. Okay. Thank you guys for watching. If you actually watched all 3 videos, be sure to tell me that I owe you a cookie on whenever I see you next, and I'll get you a cookie. Thank you guys.